All right, the sum of two even numbers is even. Sum of two odd numbers, still even. Even and an odd number, odd. Who's odd? You're odd. The product of two even numbers, like 2 times 2, is even. The product of two odd numbers, like 3 times 7, is odd. The product of an even number and an odd number, like 3 times 6, is going to be even. All right, let's move on a little more. Well, let's see. We have here an even number and an odd number, so we know that the sum will be odd. All right, now here we're multiplying. And we have an even number and an even number. And two even numbers multiplied together are even. All right, we're adding again. We have an odd number and an odd number, so that means their sum will be even. Then here, oh, okay, so this is multiplying. Odd number, odd number. If you multiply two odd numbers together, your product is even. Nope, I'm wrong. I'm sorry. Odd. But I got you there for a sec, didn't I? Scared you. So for this, we want to explain why it has an even sum. Because look, I've got an even number, and an even number, and an even number, and an odd, and an odd. So I know that these two together will be even, and these two together will be even. So if I add them together, that's even plus even, which is even. And then we add in this last guy, which is another even number, so we'll get even. You needed to explain that a little bit better, but I'm not going to make you rewrite it in this video. But your written explanation needs to be more thorough. All right, let's take a look at some greatest common factors. Any method. Well, let's see. 32 is going to have 8 and 4, and 1 and 32, and 2 and 16. And let's see, 48 is going to have 8 and 6, and 3 and 16, and 2 and 24, and 12 and 4. So it looks like the greatest common factor here is going to be 16. Okay, let's check out B. So we have 45. Oop, not 42, 45. Come on, Miss Vandenhoek. So 45, we're going to have 1 and 45. 2 isn't a factor because it's an odd number, but we know 3 is a factor because if we add the digits up, they equal 9. So 3 and 15. 5, I'm not with it today. I'm sorry, guys. 5 and 9 are also factors. If we look at 81, we have 1 and 81, 3 and 27. It's not divisible by 4 or 5. Don't think it's divisible by 6, but we know 9 times 9, and I bet that's our greatest common factor right there. 9. Then 18 and 36, let's see. 1 and 18, 2 and 9, 3 and 6. It's not divisible by 4 or 5. So now let's see, 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Now you might be tempted to look at this and say, oh, look, 9's the greatest common factor. But don't overlook it. 18 is the greatest common factor of 18 and 36. So let's make sure we have our answers in the right spot. Hopefully yours look just like mine. All right, least common multiple of 12 and 30. Let's go. So we've got 12, 24, 36, 48, 60. Okay, let's count by 30s. 30, 60. Ah, hey, there it is. So their least common multiple, 60. Now let's try 20 and 50. And I'm going to do it down here because I've got a little more room. So I've got 20, 40, 60, 80, 100, 120. Let's see if that goes far enough. And then I'll have 50, 100, 150. Do you see it? I do. 100 is their least common multiple. So if hot dogs come packed 10 in a package, and buns come packed 8 in a package, we want 1 hot dog for each bun for a picnic with none left over. What is the least amount of each that we can buy? So this is actually a least common multiple question, because that helps us figure out where the 8 and the 10 would intersect perfectly. So 8, 16, 24, 32, 40. Now I know 40 is divisible by 10 because it ends in that 0. So 10, 20, 30, 30, 40. So right here, so for hot dog buns, 5 packages of buns. 5 packages of buns, and then 1, 2, 3, 4 packages of dogs.